Now, here's a summary. If I ask what happens to the current through the battery if I add something in series, if I take a bulb or a network of bulbs or anything, and I insert that between A and B. If I separate that line, I break that line, and I shove the new stuff in every single case, the current through the battery goes down. And the reasoning is threefold. I have clogged up an existing path. That's going to increase the resistance, finish your sentence, of the circuit. And that, we know, decreases the current, finish your sentence, through the battery. Now, it doesn't matter what we add. It can be a bulb, it can be a network of bulbs, it can be a smelly dead fish. Anything you add in series is going to increase the resistance. You remember that we found the equivalent resistance for series by just adding them up. So anytime I add something in series, I'm making the sum bigger. Okay? Now, if you add something in series, you have to use scissors. You have to break an existing line and shove the new stuff in. Okay? So I would have to break the line right here. A and B are going to go dark. I pull those apart, and I shove the new stuff in and solder them in. Now, on the other hand, anytime I add something in parallel, the current through the battery goes up. Again, the reasoning is threefold. I have added a new path, a new opportunity for flow. It doesn't have to be a good path, it just has to be a new path. In doing that, I lower the resistance, finish your sentence, of the circuit. That increases the current, finish your sentence, through the battery. Again, it doesn't matter what you add. It could be a bad path. It's just got to be a new path. And you don't have to use scissors to add something in parallel. When I added this bulb in parallel here, I could just clip it on with alligator clips here and here. I'm not going to make A or B go out. I'm just going to clip them on. It might change the brightness of A and B, but it won't cut off the current through them. Okay, check that your neighbor's on the bus. Okay, folks, it's going to seem like there's lots of different ways to change a circuit, but I assure you there are only 4. There are 50 ways to leave a lover, but there's just 4 ways to change a circuit. The first way is to clutter an existing path. Now, that's going to increase the resistance of the circuit. Another way is to add a new path. Again, it doesn't have to be a good path, just a new path. That's going to lower the resistance of the circuit. Well, that's 2 of the 4 ways. And I bet you can think of the other 2 ways. If cluttering an existing path is going to raise the resistance, then decluttering a path is going to lower resistance of the circuit. Likewise, if adding a new path is going to lower resistance, removing a path, doing the opposite, that is going to increase resistance of the circuit. Those are the 4 ways that you can change a circuit.